Assalamualaikum and salam sejahtera. The third learning unit would be lipid. So these are the learning objectives for this learning unit. You should be able to define lipid and explaining different classes of lipid. Secondly, explaining what are the function of fat in food. Thirdly, summarizing auto-oxidation process in food. And lastly, explaining the chemistry of frying. So what are lipids? Lipids are broad group of chemically diverse compounds which are soluble in organic solvent. So they are not soluble in water but soluble in organic solvent. And they are referred to as fat or oil. Fat referring to the solid form of lipid and oil referring to the liquid form of lipid. Okay, so this solid and liquid is based on their physical state. So the major component of lipid are fatty acid. Fatty acid are the compound that contain aliphatic chain with a carboxylic acid group. So the majority of fatty acids of lipid would be in the range of 14 to 24 number of carbons. And fatty acids are classified either as saturated or unsaturated. Unsaturated means it has double bond. So these are the general lipid molecule structure. Consists of a head part, okay, glycerol, which are hydrophilic in character, and then the tail part, okay, which are hydrophobic in character. And this tail part can goes up to 3 fatty acids. So this is referring to one fatty acid, another tail refer to another fatty acid, the third one will refer to another fatty acid. So fatty acid can be described by systematic, common and also abbreviated names. So first of all, we will look at the nomenclature of saturated fatty acid. Now, naming of saturated fatty acid would be based on the number of carbon in the acid. So if there are 10 number of carbon, the name of acid would be decane. Okay, note that it ends with letter E due to the number of 10 carbon, but because this is acid, we replace the N E with OIC or wick, so it becomes decanoic acid. So this is very simple, basic that you have learned before. Okay, so this would be the numerical abbreviation for fatty acid. We use numerical system. Okay, for example, hexadecanoic. So hexadecanoic means 16 number of carbon. Okay, so the commercial name for this kind of acid is palmitic acid. So palmitic acid will have no double bond. Okay, so the numerical abbreviation or the numerical system for this hexadecanoic acid will be 16 semicolon 0. Okay, so 0 means indicating no double bond, 16 indicating number of carbon. Next, we will look at the nomenclature for unsaturated fatty acid, means it has double bond. So due to the presence of this double bond, okay, the anoic of the naming would become anoic. Okay, from anoic become anoic. So the numerical will be the same. Okay, as saturated acid means instead of 0 for the second number after the semicolon, you have number, okay, indicating the number of double bond. For example, here octadecadienoic acid. Okay, note that enoic here. So it has 18 carbon, okay, with 2 double bond present. Now, based on this nomenclature, you don't know the position of the double bond, but you know the number of the double bond. So therefore, to know the position of the double bond, we use the delta system. Okay, indicate by this symbol here, triangle symbol. For example, here, oleic acid, which is the common name or the commercial name, for the systematic name is 9-octadecenoic acid. So 9 is the position of the double bond from the carboxylic end, or carbon 9. Okay, so this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and in the numerical abbreviation, we write it as 18 colon 1 delta 9. So this will indicate there are 18 carbon with the presence of one double bond, okay, at position of carbon 9, okay, delta 9. So alternative to the numbering system, we use omega system. Omega system, on the other hand, indicate the position of the double bond from the methyl end. So in the delta system, it's is counted from the carboxyl end, whereas omega system we count from the methyl end. Now, the omega system is useful in the context of human diet. Okay, so we use omega system because it is classify the position of the double bond closest to the omega carbon. So omega carbon is counted from the methyl end. Okay, so this is omega carbon. Okay, then the subsequent is omega 1, omega 2, okay, carbon omega 1, carbon omega 2, and so on. So this table shows the systematic name for different type of fatty acid, their common name or the commercial name, the formula, the shorthand description, or the abbreviated name. Now the previous table shows the saturated fatty acid, okay, without presence of double bond. So this table here shows unsaturated fatty acid, means there are presence of double bond. Okay, so again, this first column shows the systematic name, followed by the common name, the formula, and the abbreviated numbering. So note that this abbreviated numbering uses the omega system. So means it is in the context of human diet. Okay, so the omega system is used in the context of human diet, where the classification of the position of the double bond is the one closest to the omega carbon. So means from the methyl end. Okay, for example here. Okay, so this is the methyl end. So this is carbon omega. Okay, omega carbon. Okay, then the subsequent is omega 1, okay, omega 2, omega 3, 4, 5, 6, 7, and so on. Okay, so if you look at linoleic, linolenic, and also arachidonic, they are classified as omega 6 due to the formula of the acid are the same. Okay, so if you look here is CH3, CH2, okay, 4, and followed by CH, double bond CH, CH2. Okay, same goes to linolenic also, CH3, CH2, 4, CH double bond CH, CH2. Okay, so the pattern are the same. Okay, so omega 6 means here, okay, the position of the double bond is at omega 6. Okay, the first double bond. Whereas for linolenic, EPA and also DHA, okay, the first double bond from carbon omega is at omega 3. Okay, so CH3, CH2, CH double bond CH. Okay, also similar here, CH3, CH2, CH double bond CH. Okay, CH3, CH2, CH double bond CH. Okay, so when this number here, okay, after the colon indicates the number of double bond. Okay, so like here, okay, the following double bond is of course at omega 9. Okay, here the first is at omega 6, omega 3, second is omega 6, the third one is omega 9. Okay, and that's how you see the position of double bond. Okay, next we move on to the classification or division between saturated and unsaturated fat. This is useful in food technology in terms of their physical properties, because saturated fatty acid would have much higher melting point compared to unsaturated ones if we compare in terms of their carbon number. Okay, so the ratio of the saturated fatty acid to unsaturated significantly will affect the physical properties of a fat or oil. Now, the scientific name for ester of glycerol attached with fatty acid is named acyl glycerols. So over 99% of fatty acids that are found in plant and animals are in terms of esterified version to glycerol. And these acyl glycerols can exist as mono, di, and also triesters. And they are named monoacylglycerols, diacylglycerols, and also triacylglycerols respectively. However, the more common names for these compounds are monoglycerides, diglycerides, and also triglycerides. So if you come across monoacylglycerol, it's the same as monoglycerides. Now the glycerol is attached to the fatty acid. So if the fatty acid is only one, it's called monoglyceride. So if the glycerol is attached to two fatty acid, then they are named as diglyceride. And if the glycerol is attached to three fatty acids, then it is called triglyceride. Of all these three, the triacylglycerol or triglycerides are the most common, okay, in food. And the usage of these glycerols are as food additives, okay, for example, as emulsifier, okay, to mix immiscible oil and water. Okay, this is how triglycerides are formed. So this is glycerol, okay, and there are three fatty acids here. So one glycerol attached to three fatty acids through condensation reaction will form triglyceride and also three water molecules. So if one glycerol attached to one fatty acid, then monoglyceride will form. And if glycerol react with two fatty acids through condensation reaction, then diglycerides will form.